Hi, good morning, good afternoon, everybody. Welcome to today's workshop. We're going to be covering Log Management 101. Some quick introductions. So my name is James Mountfield. I'm the Principal Solution Architect for Humio in EMEA. Before we get started, I just want to cover a couple of things for today's session. So this webinar is being recorded. You're all currently muted, but if you do have any questions, please make use of the GoToWebinar Q&A capability in the control panel there. We'll be monitoring that during the presentation, and we'll either talk to your questions as they come up, or I'll respond in the chat. So in a second, I'm going to hand over to Tony Reed, who can introduce himself. He's going to run the majority of today's workshop. I will be covering a section in the middle. We also had a couple of questions that were raised during registration, and I will also take those questions about halfway through this presentation. So over to you, Tony, take it away.
Thank you, James. Good afternoon, everybody. Good morning, everybody, depending on where you are in the world. Thank you also from me for joining this session this afternoon. I'm looking forward to spending the next 45 minutes or so with you to run through our Log Management 101 workshop with Humio. Quite a simple, straightforward agenda, but we're going to cover a lot of ground. So we're going to start right from the basics of what is this thing called a log, and why are they so interesting? Why are they so important? I've been working with log management solutions for a number of years now, and I have to say, in a slightly sort of geeky, nerdy way, it really has been one of the most exciting phases of my career. There's a real kind of magic that can occur with these logs once you get to grips with a tool like Humio for enabling you to gain the insight that they contain. There's a real sense of kind of excitement and pioneering kind of spirit to go into these logs, and you feel like you're entering uncharted territory and shining a light on something that's never really seen the light of day before. So I'm going to try and convey some of that potential and some of that excitement today. So we're going to look at some logs in general in Humio and cover off why log management, and I'll give you a few examples from the work I've done over the years as to why I have that sense of excitement that I mentioned. Then I hand back over to James, who's going to talk us through some of the principles for getting data into Humio, and then come back to me for this particular use case that I've been, well, for a number of years now, really evangelizing, which is a kind of a slightly unusual use of logs for what I've just called establishing patterns, and such that you can then spot outliers. So that's what we're going to be covering. So without further ado, what is a log anyway? Well, one doesn't have to go very far to come across a log. This is just from my MacBook, the system log. Logs have been around since the first day the computer was invented, and probably other things besides. Ever since computing's been invented, operating systems, applications, hardware has just had a habit of capturing just about everything they're doing and writing them out initially to log files squirreled away somewhere on the hardware. And as you can tell, they're not the most gorgeous things. This is say a fairly old-fashioned one, but it's certainly not going to win any beauty prizes. And to be fair, none of them probably would. But the fact is, everything you're ever likely to want to know about what's going on is contained within those logs. And as our digital world increases, the number of places where these logs are maintained just increases and increases and increases. And it really is the companies who have solutions in place that enable them to see the contents of these logs and get to grips with them, get their arms around them, as I like to say, in real time. They're the ones who ultimately have a competitive advantage. They operate faster, they know what's going on, they can respond to changes quicker, they can fix issues quicker, because everything they're likely to want to know is buried away in these logs. If you kind of want to go back in time, before log management as a kind of an industry was created, people who worked in IT at that time, if there was an issue, they would go and look in the logs. We didn't call it log management then, but they would have to probably start off by consulting their list of usernames and passwords such that they could log on to the various machines involved. They probably have got some irate phone call in the first place telling them that there was an issue because they weren't looking at the logs. So how would they have known there was an issue? So if someone's had to tell them there was an issue, they then had to do this merry dance of trying to find out what machine it is that contains the log that they want to go and look in. They have to get the credentials, they have to phone people up, they can't remember them, they have to, you know, etc., etc. They finally find the log. That log points to another log, and the process kind of repeats. They have to log onto another machine, they have to go and find the log and start using all sorts of weird and wonderful OS operating system utilities to grep the logs and vie the logs and look at these things and try to find, as you can see from the one in front of you, there's a sort of a timestamp. You know, just about all log management is time based. There'll be some sort of timestamp on the log entry telling us when the thing occurred. These ones are not a particularly high level of fidelity on the time, but you know, logs tend to have a kind of a fraction of a second as well, down to the thousandths of a second and beyond. So you can, on the time, you know, based upon, you've got this irate person on the phone saying that at 11:30 last night something went wrong, so you go and find the log entry starting from 11:30 or maybe a bit before. You look in the logs, and when you finally find the one that's the important one, lo and behold, there is the indication that the thing was going wrong. But by now the lights have been dark, everyone's been sat in the dark for hours on end, tempers are frayed, and you've finally just started the whole problem of being able to troubleshoot the issue. So the first sort of log management vendors were all about, well, let's do away with all that logging on and sort of swivel chair analysis. Let's get all of those logs into a single place and enable you to do some sort of overall search across all of those logs to cut down that whole troubleshooting process and reduce your sort of mean time to recovery to get the whatever it is that's gone wrong back on its feet. So just so that you don't have to sort of squint and strain your eyes to see, just blowing that up a little bit bigger. Although it looks fairly unattractive, you can see there kind of is a pattern to it. There's obviously the timestamp which indicates the beginning of each kind of entry or event or whatever you want to call it, record in the log. I tend to use the word event. There's the timestamp, as I said. Probably normally we'd have a more detailed timestamp, but anyway. And then there's this kind of consistent sort of format where we've got this ASL module and then some com.apple.cd scheduler, and the one below is a com.apple.install. So it actually does have some sort of a pattern. And as you'll see, log management solutions, or certainly you know, modern kind of good ones, are able to deal with that sort of pattern matching within the log to strip out the interesting fields and start to aggregate the interesting fields across all of your log entries. We'll see that as we come into an example. What produces them? Well, as I've alluded to, just about everything, and the list increases more and more every day. So, you know, there's these great stories. By the time you've arrived at work, back in the day when we used to be able to travel to work, you've maybe interacted with, you know, numerous systems by your mobile device. You've done a bit of financial banking, you've read your news app, you've bought your latte online, you've bought your train ticket online, you've done some I guess to bring that more current, you've done some you know, sort of WhatsApp or remote working. All of those things, all of that infrastructure that you're interacting with is generating these logs at a vast scale. It's mind-blowing now, and the you know, if you read any of the industry sort of papers on this, it's just going to keep on increasing. And what Humio and what we're all about is bringing all of that data, ingesting it, and enabling you basically to run queries and reports and dashboards against that data at light speed, at vast scale, super responsive. So as quickly as possible, within seconds, less than seconds, you've got the data from wherever it was generated, populating dashboards and reports and alerts to enable you to answer any question. And this is the bit where I guess I get quite excited and find this whole field so interesting. It really is. You can talk to anybody about log management. Everybody has something. Everybody in industry has something that they're kind of interested in. That the logs can provide some sort of insight and some sort of clarity around. So you really can, using Humio, ask any question of just about anything. I mean, there's a couple of caveats. Log data, we're talking text. It's text-based, so we're not into images or videos or things like that. It'll be text-based. It's the kind of metadata, perhaps, that goes around that information. But there's just a massive breadth of information that's already out there. And the great thing is, you don't need to change it. It's already out there. You don't have to do anything specific other than the bit that James is going to talk you through. You just bring it in its current, natural, original form, get it into Humio, and we'll provide a fantastically sophisticated query capability that allows you to spot what's going on right now, and then, as I'll show you in that later use case, do some really clever numerical analytics, or exploratory analytics, I like to call it, where you do feel like you're the first person ever looking at this data in real time, so you're seeing it as it's happening. It's a real feeling of empowerment about, and then just, you need to be the type of person, however, who has that sort of, I guess, natural inquisitive sort of mindset that you ask a question, you get an answer, and it makes you think of another question, and Humio, lets you answer that question, and you'll drill down into your data, and you'll find interesting characteristics about it using that search language, and ultimately you'll probably think, oh, that's something now that's really worthwhile and reusable, and you'll create some sort of a dashboard such that people who are not familiar with the search language can just go to the search board up on a NOC or a SOC or some sort of monitoring operations center. Your dashboard will be up there telling everybody exactly what the state of play is regarding the specific thing that they're interested in. So you might have a number of different dashboards, obviously bringing together information from all sorts of kind of correlated activity. Not just about dashboards, I'll make that point now, also alerts. It's all well and good having a dashboard, but unless you're then, I suppose, if you're going to pay somebody to sit in a chair, strap them to the chair in front of that dashboard and say, when that thing changes, when that number drops below a certain value or goes above a certain value, I want you to run over there and create a ticket or send an email or send a text. That's obviously not ideal. So Humio instead can just create an alert. So based upon your response, your query, it can then check for the response condition. And as I say, if there's been a significant drop in the number of events or a significant uptick in the amount of activity, or a particular value that you're monitoring has changed in whatever way you are interested in, then Humio can create an alert and call out to any number of sort of webhooks with an appropriate message based upon the information that it's derived from the query that generated the alert. So what generates logs? As I said, just about everything. And log management is all about gathering all of that information centrally. So the whole swivel chair analysis, the whole logging onto multiple different places, all of that change. You've just got this single pane of glass, to coin a phrase, that allows you to go and look from that single pane of glass at any log from any source. And as I said, ask any question of it. So let's go ahead and actually have a look at what these logs look like in Humio. So here is our Humio interface. It's got a, if you've not seen it before, there's a kind of a Google-like search bar across the top here where I can type in my search parameters. very much differs to Google is we have this sophisticated time picker for enabling you to zoom in on a particular time frame. I'm currently looking at the last 24 hours of this particular repository. We're collecting information from a number of different Windows servers here. I'm now running this query live, so it's looking at the last 24 hours. You can see the events as they stream in. In that last 24 hours, I've already it's telling me that there's in the last 24-hour time frame. So obviously from this same time yesterday, we've had in excess of, well, just over 1,070,000 events, and you can see them arriving as they come in from those different host machines out there. We get this nice kind of pictogram. We're going to come back in a minute and sort of try and see if we can find out what this little spike here is all about. But for now, just because I've asked for the last 24 hours, because it's a live query, we've got each pillar here. It's telling me, gives me the time frame that bar is associated with and how many events occurred within that bar. The one at the end here is still filling up, so you'll see that one, actually the one just over. That one there is a little tiny one because we've just gone into the new 15-minute interval. It's just 16 minutes past 3 o'clock in the afternoon, according to my clock. So this bar is just starting to fill up, and you can kind of see those events arriving and the corresponding updating screen in the background. If I actually just go ahead and stop that query so we can actually look at one of these events in a bit more detail. As I said, these are Windows Server events actually, so we can have a look at this one. Just clicked on one here and it shows me that particular event in a lot more detail. We've got some information about how it was collected, which as I said, James is going to come back to, but then we've done this, Humio has done this sort of interesting fields or known fields analysis on this event. We've got the raw string that was passed in here, so we always store the raw string of the event, but then things like the timestamp, as I mentioned right up the top of my presentation, all events have a timestamp. That's how we can correlate them. That's how we can show them chronologically on the screen. Then moving on down, we've got things about the event itself, the event action, the event codes. That's the Windows event code there. And some other information that's just being extracted as the data comes in about the event. So the application, the Windows event, the Windows application that created it, the destination address of the event, the destination port, etc., etc. So all sorts of rich information about each event. Bearing in mind, we've received 1,072,000 events here. What we have over here is kind of an aggregation of the last 200 events in this query. So we can see things like the event action that we talked about. So each event has a particular event action, and we can click on this over here and see what the different event actions are. So the one I particularly looked at, you can now see that of the last 200, then the majority of them have been this filtering platform connection. Now, I don't particularly want anybody on the call to, don't worry about the fact that you may not be a Windows Server administrator. Just get the impression that we're extracting all of this rich kind of contextual information from the event itself. We've got the event code. So again, all Windows event codes have one of those. If we scroll on down, we've got things like the come down here, we'll find the application that I mentioned. So we've got all of the different applications that have generated these events, and even a little bit further on down too, we've got things like the target. So now you notice not all events have got this particular event. This is the target username. 19% of the events have a target username, and the ones that do have got one of these 13 values. So as I said, I'm going to try and do a little bit of analysis to see if we can get to the bottom of why we've seen this just after midnight. So this is the point at which the last 24 hours. This is where Wednesday began. So these are the 15-minute intervals after midnight, and then there was this slight kind of uptick in the data. Now the first thing I'm going to do is if I come back to my agent.type. And I'm going to do a time chart. I'm going to start to use the query language that I talked about and just do a time chart on there to see whether where that uptick occurred. And I can see that actually it occurred in the events, which were the Windows log events, not in the metrics. So I can kind of, in order to do my analysis of trying to work out where this uptick came from, I'm going to go ahead and just do a search specifically for that particular type. So let's do agent.type equals winlogb to eradicate all the other ones. And now I can see my uptick in time. I can actually use that. I can just zoom in on the particular time interval that I'm interested now. So now my pictogram is going to change slightly. Each bar now represents a 30-second interval, so it's kind of flattened out a bit, but you can see a much higher level of fidelity around that now, whatever it is, 5 minutes. So 1 hour, 50-minute interval. I've gone from 125 to 215 to look at that peak. And now what I'm going to do is just to perhaps I saw there was an interesting field called event.action. I could maybe have a look at, so during that time period now, what were the predominant event actions? And I can see that most of them were of type filtering platform connection, whatever that is. But I still can't really tell from this particular view is whether or not that event action is responsible for the various peaks here. So I can change my top command, which gives me the report there of the top 10 event actions, into a time chart. Basically, Humio provides numerous commands here for doing this type of analytics. Notice the blindingly fast speed. So I've just reissued my query there. It's fetched 42,000 events. I mean, not a particularly massive instance, this one, but nevertheless still pretty impressive performance. And Humio absolutely flies. It's been architected for modern hardware. That really is one of its USPs, is that it makes fantastic use of modern day computer hardware for doing blindingly fast searches and really enabling this type of analysis. So now I can see that actually this that it is actually this filtering platform connection which is responsible for my peaks in this traffic. When I was first given access to this instance, I was told it was a kind of a honeypot out on the internet, just to see what sort of traffic it would generate. So I was expecting it to be all kind of log-on activity, but you can see that actually what's causing that peak just after midnight isn't log-on activity. But I can use the capability here just to remove those other event actions and see. Now I can see this green is now my log-on activity. So I can actually see that log-on activity is occurring, but it's not responsible for the 1,000 plus events that were occurring during that peak, and so on and so on. You can kind of play around, poking around in your data, producing this type of analysis, and ultimately creating dashboards along these lines. So in the best traditions of, here is one I produced earlier. This is a dashboard that just has lots of different widgets on it. But if I edit this and show the queries, you'll see each one of those widgets is just a derivative of the types of searches I was doing there, using the account command and the top command you saw, probably some group by. So very intuitive sort of language, the search interface. If you've used any other sort of log management tool, you'll be immediately up and running with the search interface. It's all very well documented. But as I say, the one thing you will notice striking is that performance. Right, let's go back to the slides. So in terms of why log management, because I think I've made this point already, if you know the logs, you will be the wise one. I've literally walked into customers' offices and, well, not wanting to sort of blow my own trumpet, but one of my customers used to call me their data hero, because I could sit down in front of their log management tool and delve around and poke around, because I'd got familiar with that programming, with that query language that we're talking about there. I was their data hero. Every time I went in there was a new group of people who wanted to speak to me about their logs to show, such that I could demonstrate to them the type of insight they would get from their logs, their part of the business. So if you want to be known as the data hero, then I can't recommend highly enough you get to grips with log management. Logs really do answer everyone's questions, from the kind of classic traditional IT and network operation type use cases, like, you know, have my servers got too much load or too little disk space? When are they going to, have they crashed? When are they going to crash? See which users are doing what on my systems, which elements are producing too many errors, through to security use cases. Obviously, that's probably the two main: log management, security, and IT ops. You know, access to resources. Security people love log management because it tells them exactly what's going on, so they can see when, where, who, what sort of activity, what kind of outbreaks, what unusual or anomalous or first time activity is occurring. So, you know, put one of those people in front of Humio with the right, and because of their sort of background, they'll probably be up and running, writing their own queries within minutes. And then the more, in some ways, the sort of the less obvious, but in some ways more interesting sort of use cases. The kind of, I've just put a bit of a catch-all list of business analytics. This is I was chatting to somebody recently who was telling me they'd done some work with a train company who'd done a load of fraud analysis on ticket buying, because they were logging all of the data of the conductors going through the trains buying tickets. They noticed that certain individuals were buying tickets online on their mobile phone just as the the ticket collector came into the carriage. They could see them arrive in the carriage. They would then use that as a only at that point would they buy the ticket, so they could buy the ticket just for the duration of the journey, not for the element of the journey that they'd already taken. And just by looking at all of that kind of activity, correlating that information from different sources, the online ticket booking, the person using the ticket checking device in the carriage, they were able to spot this kind of anomalous behavior and identify repeat offenders who are using this as a way of saving themselves some money on their daily commute. And other useful and interesting use cases. The one that I'm going to tell you about just after James has done his bit on getting some data in.
Brilliant, thanks, Tony. If you can just stay there on the slide for a second. So we had a couple of questions come up during registration, and we've had a question while we've been talking. So I want to go through those quickly. Now, we're trying to keep this session pretty technology agnostic, but there have been a couple of questions specifically about Humio, so I just want to spend a few seconds on those. So one of the questions that came in was talking about the costs of using Humio compared to other log management platforms, around 7 terabytes a day of ingest. So just a couple of key points. So Humio is designed for really scaling up those sorts of ingest numbers. Lots of other vendors talk about dozens or hundreds of gigabytes per day. Humio has some customers running in excess of 100 terabytes a day through the platform. Now, what we can do is we can build a very detailed TCO analysis with you. So we'd encourage you to get in contact to build that out. We will give you the results of that. We'll give you pretty much the model of how it's built. And the one thing that I can assure you is that Humio is going to do that using a significantly less infrastructure than you're probably used to and probably think would be possible. And also the way that we do our licensing. Humio's taken a really hard look at the market and understands that getting the price right for the relative value of the data that you want to ingest is critical. Another question's come in saying, what are the Humio differentiators from the top SIM providers? What I'd say is, Humio is not an alternative to a SIM. If we look at the sort of organizations that use the traditional SIM tools, what we can really classify them into two groups of users. So the first group is, those organizations that have a requirement to demonstrate that they're using something like a SIM or doing some sort of log management. They install it and it's a box ticking exercise. They're generally not going to extend that use case to use something like Humio. The second group of users are those that take security extremely seriously, that have taken an enterprise SIM product for what it can give in terms of immediate value, in terms of like pre-built rule sets and that sort of thing, and are looking to complement that with a tool that gives the team the ability to do proper forensic investigations, maybe go threat hunting. Humio is going to give you the ability to hold 12 or 24 months of raw data across all of your data sources for your security tool, which, a SIM with its sort of traditional rules engine and parsing is designed to sort of compensate for the fact that storing that much data is a challenge. So it's complementary, it's not really an alternative to. And then the last question was, should logs be collected from end user devices? So I'll talk a little bit more about this in my section anyway, but Humio itself is not actually concerned too much with the collection of the data. So we don't provide data collectors. We integrate with essentially the best of breed open source and proprietary collectors. And having information coming from endpoints is just as valuable as everywhere else. So I would say yes, Humio would recommend collecting information from end user devices. And what you'll find is that Humio makes that sort of log everything proposition much more reasonable and realistic. So a couple more questions actually come in while I've been talking. So how much maintenance is needed by a customer to get search performance at scale in Humio? And the answer is it's very, very low. So Humio is a relatively young product, relatively young company. So the actual application has been built with the intention of being deployed in modern infrastructure. You can run it in Kubernetes, you can run it as a Docker image, or you can do a sort of a plain install. And it is natively designed to be run as a cluster. So extending that cluster out is pretty straightforward. Now, we have a really interesting report on our website. So we've proven that we can do 100 terabytes a day with 25 nodes. That sort of proposition with alternative tools, you very quickly get into the 200, 300, 400 node size clusters. So that's where a lot of this TCO comes from. How do you get the speed without indexes? So that's a really good question. What I'll do is I'll actually show you a blog post that we've got on our website in a minute. That gives a bit of an insight as to how we do that, but ultimately it's done by pretty extreme compression of the data. Question about setting retention times, really good question. So Humio can retain your data really for as long as you need. And we can do that based on an absolute time, so an absolute age of events, or we can do it based on allocating a certain proportion of your storage. So, get the disks to 80% full, or maybe you're using something like S3 storage, in which case, you can manage that with, S3 life cycles and sort of absolute age limits. Right, question about schema on read versus schema on write, so comparing Splunk with ELK type models. Humio is much more sort of schema on read type, but it doesn't rely on building any sort of schema. So everything you see from Tony's demo of the fields down the left-hand side and what fields were available to him, that is information that Humio has derived at query time. So we use parsers to do some pre-processing if you want to, but it's not actually required. All of the information in the messages can be parsed and queried as you go. I'll do one last question quickly while I'm here. Thank you. Okay, that was easy. So let me switch over to my presentation here. And I'm just going to talk for a few minutes around some best practices for data collection. So change presenter to myself. Okay, so you guys should be able to see my screen at this point. So I'm going to talk a little bit about moving that data around your estate. Again, I'm trying to do this from a technology agnostic point of view, and I'm talking about some of the best practices that we've uncovered over the last few years. So really it comes in 4 stages. So the first one is collecting the data. Second one is formatting it, and then routing it and transmitting it, and then receiving it into your analytics platform, whatever that may be. So data collection. This generally comes in a few standard ways. Now we talk about log files, but really we mean any sort of human readable machine data. The most common data collection is going to be tailing a log file. It's often referred to as tail from like different plugins. But there are a few other options. So things like streaming events. You can think of Syslog as kind of an event streaming protocol, but we can also integrate with things like Kafka, and we can take things from sort of messaging queues from AWS and all that sort of thing. So that's another source of our data. One of the newer ones that's becoming more and more important, though, is this polling for events, or going out to cloud services and pulling audit APIs. So this is why we've moved away from talking about log files and started talking about machine data, human readable computer data. If we're using something like Okta for our single sign-on and our identity providers, Okta does not provide us with a log file of what happens in that environment. They have an API that maintains an audit record. So that now becomes part of our data collection procedure. So it's not just about pulling data off of disk. We have to think about all of the different data sources in our estate. And it's the same for metrics, pulling machine state. But you can extend that out to anything. You start thinking about IoT, pulling machine state off of thermostats in people's houses, because that's the sort of thing that you get to. Now, the next step from collecting that data is thinking about how we're going to do formatting and transformation. And you have a few options. You can either transmit the data straight through as is, rely on the analytics tool to do the normalization and parsing and interpret that data, or you actually have the opportunity to do that at the middle layer. And it really depends on sort of organization you are and whether you can mandate that sort of thing. So, we've done a lot of work with some financial organizations that have very top-down management and sort of strategy. So it's very easy for them to mandate a standard logging format across the entire organization. And I only know a couple that have actually really achieved that. That brings some really good benefits in that you get very consistent reporting from all of your applications. You don't have to reinvent the wheel per application team, but it does require that very much top-down command and control type of organization to make it work. The other thing that is really helpful to try and think about at this layer is event tagging and enrichment. So to understand where this data is coming from. It's very common, or it can be pretty common, especially in poorly thought out deployments, that you end up with a lot of data in your analytics platform, and sometimes it can be hard to work out where it's actually come from. So just ensuring things are consistently tagged with the host name that generated the data, maybe the service that it's related to, et cetera, et cetera. So really think about what you're going to do with your data across your organization before you actually send it to any end service. Now, as I said, Humio itself does not actually provide a data collector. So we integrate with all of the best of breed open source and proprietary tools for doing this. So we've done a lot of work with Vector, which is a new collector agent. That's got a huge number of options for parsing, transforming, enriching messages as it passes through the system. Very, very similar to something like FluentD. Anyone that's done a lot of work with FluentD will be familiar with those sorts of concepts. The other thing that you'll see is the sort of the best of breed proprietary collection technology as well. So the Beats tools from Elastic, they're very good in the way that they can not only collect data, but actually transform it and normalize it at that collection layer. And things like the Splunk Universal Forwarder has a lot of those capabilities as well. So I would really try and encourage any organization that's building out a new collection and sort of machine data management initiative to really think of that collection and transformation layer as having some of the same attributes as you'd want from an ESB. The ability to move messages in a standard format, to tag them with consistent metadata, and generally make them available to multiple end services. And that's really where this routing piece comes in. So I'd always advocate that your data collection and enrichment layer should, as much as possible, be agnostic to the target service that you're sending that data to. This is something I actually encountered a lot when I was working more in the sort of software development lifecycle. People would take their issue trackers and integrate it with their build systems and then their version control, and they do it like point to point. The trouble is that locks you into those specific vendors with those point-to-point integrations. You know, if you can create separation between your data collection and the target service, you're going to give yourself a lot more flexibility to send those messages to the relevant services that need them. So if we think of a traditional SIEM environment, plus something maybe like Humio, and then plus maybe a data warehousing tool like Snowflake, you know, you're going to want to route messages to one or more of those different services, and that separation can be really useful. The other thing I would just point out is that not all protocols are created equal. So things like syslog, really good on local networks, but trying to send syslog data over a WAN securely is just, it's hard. I really like this diagram actually that they have on their website. This is a really good way of thinking about it. All of those different data sources you may see, using that collection tool to really give this data structure, maybe do sampling and aggregate work, and then forward it onto the relevant target services, whatever suits those different data layers. Now, just a little side note on Humio again, as I said, we don't provide a collection technology. We integrate with probably what you're already using, or we can make some best of breed recommendations if you're looking to use something new. What that means is that you know, Humio customers are pretty much guaranteed to not suffer from this vendor lock-in. Because of the interfaces we present to that collection layer, you could actually take Humio out and put any other product in, and that's the flexibility organizations really should be looking for. You know, I'm not advocating moving away from Humio, but having that flexibility is something that's really going to be valuable long term. Now, the last step is how do we receive the data into those services? Again, this is where the data transport question starts becoming really important as you scale up these sorts of things. So if you're moving, you know, a few hundred gig a day, that's, you know, that can be coped with. You know, you'll find that the default settings for tools can, you know, are going to work pretty well. If you can tolerate a few seconds of latency, defaults are going to work pretty well. As you start getting up to dozens or hundreds of terabytes a day, you're dealing with a real data stream. It's no longer something that can be you know, chunked and sent from a single collector. You really need to think about how you're going to stream this data. This is when you start moving away from sort of the standard tools like Logstash or Filebeats or Fluentd, and start looking at building, you know, really high performance data streaming over things like Kafka and that sort of stuff. So again, it's something you need to consider as you scale up. Same for people working with cloud environments. You know, if you're taking information out of GCP or AWS, you can start thinking about dead letter queues and, you know, persistent queues and all that sort of stuff. And, you know, Humio is absolutely able to help you with making some of those decisions as well. And so one final note on Humio. So some tools require you to describe the schema of the data when it arrives at the service, and they become particularly sensitive to that data structure changing over time. Humio just takes structured or unstructured data, and it really doesn't matter whether it fits the parsers or not. Parsers are there for user convenience. If the parser fails for any reason, Humio still takes that data. You know, you can deploy Humio as a reliable system of record for your data, as well as, you know, being an analytics tool and something that analysts can take advantage of. So I've gone through that really quick. You know, if there are any other questions, please feel free to drop them in the Q&A section as we go through. Otherwise, I will hand back to Tony.
Thank you. So this is me now, is it? Thank you very much. Oh, good point. Sorry, James, not the smoothest transition. There we go. Right, so just one last, maybe I'll do this as quick as I can. Let's try and get this done in 10 minutes. This notion of using logs to establish patterns and spot outliers. As we've already seen, log management can tell you exactly what happened and when, but it also provides you with this super sophisticated analytics capability. I think of it as having like a spreadsheet bolted on top of a real-time flow of data. And so that means you can perform really sophisticated aggregates at light speed, create these characteristics and spot anomalies. I first did this when I was working for a UK telco. They were providing, they've spoken about this at public events, so I'm not giving away any clues. I won't mention any names, but they wanted to know, so they provide broadband connectivity to about 5 million UK households. And we were having this conversation one day, which sort of said, if only we knew everything was normal, we could kind of relax. And the everything they were referring to was about 75,000 different network components. And if they just knew that each one of those was behaving as it tends to behave, then they could literally relax. But because they weren't able to answer that question, they were never able to relax. So we tried to set about seeing whether we could actually answer that question. Can we tell when everything is normal, or I suppose more importantly, can we tell when certain things are abnormal or atypical? And what they had was lots and lots of historic data. I don't have access to their actual telemetry today, but I'm just using going to improvise with the data we were looking at earlier. And this is a 5-day view of those Windows logs. So, and this is kind of where we started with those kind of roadside cabinets. You can't do this at the kind of individual household level. We know our broadband usage tends to be as individuals fairly haphazard, but if you take it at a kind of a neighborhood, a couple of thousand homes in a neighborhood supplied by one of those sort of roadside cabinets that you may have walked past occasionally, then at that level, you can start to look at the sort of the telemetry that they were already collecting over a period of time and start to spot a kind of, in their case, it was a kind of a weekly trend. And on average, each one of those roadside cabinets would be, at its busiest on a kind of a Monday morning, when I guess everybody was downloading their email and getting ready to go to work. It was busy on a Friday evening when people were downloading their latest Netflix thing. And there was a kind of you could see it in the data. You could see a repeatable flow. It would kind of repeat. Each Monday was a lot alike. Obviously, there were Christmas days and such like where it didn't work. But on average, typically, we looked at the data and recognised that we would be able to use their historic data and create for each of those roadside cabinets what a typical week should look like. What a kind of we used to call it the happy corridor. What the upper and lower kind of performance characteristics should be. The idea being you could then show run a query which showed you which were the components most in distress, most out of character, most highest above their limit. And that's literally what we set out to do. It was sort of a couple of days exercise. They had the data already, months and months worth of it, and we just created for each one of those components, we created a baseline of what we expected the traffic to do. That became our kind of, is it behaving normally? And the first time, I'll never forget, the first time we kind of loaded the dashboard, we had this kind of top 50 list of most out of character network components. And it would be on a per 15-minute interval. So every 15 minutes, we had calculated what the volume should be for that 15 minutes. And there were network components that were kind of 10 times higher than where they normally were. And the question was, why is that? And they just wouldn't know. So they did. One of the quotes was actually, we could pay somebody to sit in front of this dashboard, and every time it refreshes, they would have something valuable and worthwhile to do. Literally, the first time the dashboard refreshed, they created a P1 off of the top 3 or 4 entries from this report. And as I say, I don't have access to the actual sort of data today, but I just wanted to very quickly run you through the type, how the pattern kind of works. and I will do it really quickly. So here's that same, I'm looking here at the last 5 days, and you can kind of see even on my fairly noddy sort of data, it does have this pattern. There's this recurring pattern. Just after midnight every day there is a peak, and on the whole it's actually a fairly consistent peak. And then the rest of the week, these are days. The rest of the days are fairly consistent. So here we have a kind of a daily cycle. In the telco case, it was a weekly cycle, but the pattern, very much sort of carries across. So this bucket command is sort of pretty much the one that does all of the heavy lifting. You'll be impressed again just on this relatively lightweight bit of kit. We're running that over those, whatever it is, 5 million events. It's grouped it into these buckets of 15-minute intervals. And if I turn it that way up, you'll see this is the current 15-minute bucket still counting up. But what I now have is 15-minute intervals for the last 5 days, every single 15-minute interval with a value for how many events to expect, or no, sorry, how many events occurred in that 15-minute interval. You can just, using some of the Excel spreadsheet-like capability that I mentioned, we're now just going to enrich that with the date element and the day, hour, minute element, just extracted from the bucket, which is the number of milliseconds since whenever it is, 1970. So you can see, this is last Friday at 14:15, 5 days ago, last Friday at 14:30, 14:45, etc. If I just sort that slightly differently, you'll see, because I've got 5 days, I've got 5 lots of the 0000 15 minute, the first 15 minutes of each of the last 5 days. And there's the value. And the kind of concept was, the pattern was, if we just do something really simple, like take an average across those 5 values, if we take an average, then that will be our, and then take a standard deviation, which is what this command does basically. This group by is now applied to that previous list, and I'm saying group it by the hour and the minute. So now I have my typical day based upon the last 5 days. In the first 15 minutes of the day, all I actually needed was the upper and lower values that are over here on the right hand side. But just to sort of show my workings out, if you like, these are the last 5 days values. There were 5 data points for the 5 days. There's the average value that's based upon those 5 values. There's the standard deviation. You can see there is nice consistency in this data. We've got a relatively small standard deviation. So now I can create an upper and a lower value just by using 3 times standard deviations in this case. These were actually the values that I actually required from that. So sort of taking away I've now got kind of a lookup. So now the idea is, so let's use those values in a report, looking at the last 24 hours now. So now I'm just looking at the last 24 hours, doing the same thing, grouping that into 15-minute intervals, and then this final example just joins those 2 queries together. So I've got my last 24-hour value combined with the upper and lower. So I can see in the last 24 hours, we did not breach. It did not go either up below my upper or below my lower or above my upper. But actually here is one, I just arbitrarily picked the value 5,000 to show where the value has, in this case, fairly significantly popped above the upper value. You can actually graphically represent that. That's the last 24 hours. And this is it's a fairly tight corridor actually, but you can just about see some breaches. This line along the bottom is just supposed to be kind of pointers. There's not actually any data there. I'm just using that as a pointer to where the breaches occurred. And nice. I haven't got too many, so it's not going to be too noisy. I can obviously tweak this and refine this. And this was the one that within 15 minutes of it occurring, we were able to tell when a breach had occurred, and even earlier, if it was going dramatically above, then this dashboard now is just showing for the current 15 minutes, we would expect it to be somewhere between okay, not a particular very good example, unfortunately, but somewhere between 1,300 and 16,000, and it's currently sat nice and safely smack bang in the middle. That, in essence, was a slightly more advanced kind of use of log management. I've used it time and time and time again. Now it's something that people are really sort of comfortable with. Everyone's got a thing that they're interested in, and and the pattern kind of seems to apply. It can be tweaked and extended and used over and over again. Rather awkwardly, just getting back to my slide deck.
Yeah. So, sorry, Tony, I just want to interrupt there for a second as well, because one of the questions we had was about performance of Humio and index-free search. So, in Tony's example there, he's querying and essentially reparsing and aggregating on the fly over 1 million results there, and I mean the tool is responding in considerably less than a second. This opens up a huge possibility to go back and run these sorts of queries over days or weeks or even months of data without having to have pre-processed this into a metric data store or anything like that. This is coming from raw textual log data. You can just see
that. There's no, and it's having worked in the industry for a few years now. I'm glad you pulled me up on it, because it's something you very quickly get used to. But it's very, very startling when you first experience it. So there is that 5-day live query going on. One of these values you'll see sort of chunking away as the last most recent 15-minute value is just constantly being calculated. And the ability to use these live queries so liberally within a Humio instance, again, just really does sort of revolutionize the type of thing you can do. I'd have absolutely been into the world of doing some sort of aggregates and trying to do something here to help the system along, whereas because of the way this has been architected, and it's just quite happy to have these live. In which case, do you want to be a data hero? If you do, then there's some links on the next slide which will enable you to get to some Humio and do a download and get some additional information. And if you'd like to have a further conversation with any of us, then there are some. I'll put that up, and James, if you want to rattle off any more Q&A.
Yeah, so we've had some really, really good questions actually coming in while you've been talking, Tony. So we probably don't have time to get into all of them now, and some of them are very Humio specific, so I don't want to cover too much of them. But everyone that's asked a question on the webinar will absolutely be following up with you to give you some specific answers. And to the gentleman that's asked 10 questions, I will definitely be talking to you. We'll jump on the phone and go through some of that content as well. So I think we'll probably wrap it up there. Let me just bring up my notes to make sure I cover everything on the wrap up. So all the questions have been logged in GoToWebinar. I hope you guys and girls got a lot of value out of that session. It is going to be recorded, so the recording link will be sent out to people as well. And just like to say thank you for your time, Tony. I don't know if you want to say goodbye to everybody. It's been emotional.
Yeah, it has indeed. Goodbye, and thank you very much indeed for your time today.
Great.